Hello, welcome to a new problem. Today we're going to do two sum. Number one, it's an easy problem in LeetCode, and I already solved it, but I feel like it's a good thing to just review and go over because I have an exam about LeetCoding on Tuesday, so in 2 days basically from now. So why don't I just go over it because it uses some tools that we can use in my midterm maybe. So yeah, so I'm going to go ahead and explore this problem by understanding the input and output and going through some examples and exploring what approaches we can do and planning that for the approach and then implementing the approach and then reviewing our implementation and evaluating it. So let's do that. So, oops. Right, so whenever I like to explore the problem first, I just like to read over the problem line by line and read a couple times. So here I go. Given an array of integers, nums, and an integer target, return indices of the two numbers such that they add up to the target. So let me read that again. So our input is an array of integers, nums, and an integer target. So inputs, we have two. So we have an array of ints and an integer named target. Oops. Okay. And for our output, let me read it again. So for our output, we need to return the indices of two numbers such that they add up to targets. So two numbers, and we can put that into a list encapsulated in the list. They represent indices, indices of indices of their values add up to some. Okay, I'm going to say returns indices of elements in an array, and I'm going to just, there you go. The values add up to some. Okay, looks better. Okay. So just to repeat our input, we have two things, an array of ints named nums and an integer named target. Then our output is going to be two numbers encapsulated in a list that represent the indices of elements in the array where their values add up to some. Okay. So now that we know that our input and output, let's go over some examples. So example one, let's just say that, oh, actually, let me just continue reading it, right? Notes. So if we continue reading the problem, it says, you may assume that each input would have exactly one solution, and you may not use the same element twice. So we have some constraints and some, we have some constraints for the input and for our output. So constraints input, not really constraints, but like a given. There will always be a unique, there will always be a solution. Then for constraints on output, we can't use same number. Can use same index value or solution. Okay, so those are some good things to note. Then for some questions I would like to ask is like, oh wait, no, I don't need to ask the question because in the constraints already say that there will always be a solution. My question would be like, what if there was an empty list, right? So yeah. Wait, actually, a good question is like, what if there was an empty list and target was... No, that wouldn't make any sense either. So yeah, just ignore that question. Because if it was empty, we would need two indices. And then with the empty list, we don't have any indices in the first place, so yeah. So now that we got over the input and output, and we took some notes about some constraints for our input and output, let's go through some examples. So let's just say that our input is going to be the array of 1, 2, and 3. And then I guess our target is going to be equal to 3. Yeah, I think that makes sense, yeah. So if you look at this, if we go through the array, 1 plus 2 is equal to 3. And so our target, so that equals our target. So we can say that our output is going to be, again, the two numbers in a list, which their indices, which the numbers represent the indices of elements in the array, with values add up to the sum. So in this case, 1 is at index position 0, and 2 is at index position 1. So we're going to return a list of 1, 0, and 1, which is their indices. That represents their value. Yeah, that has those values, right? And then yeah, that's a good example. So let's go with another example. Maybe something that's not that obvious. So let's just say we have 1, 3, 5. Oops, so it's 5, and then 7. And target is equal to 12. Okay. So if we go through the list, we know that 1 plus 3 is not equal to target, which is obvious. Or we can do it this way. We can say target, so target, which is 12. So 12 minus 1, that is 11. So minus 3, that's 9, right? Is that correct? Yeah, that's 9. 12 minus 5, I can't even do, well, 12 minus 5, that's 7, right? So in this way, we're using a complement to find our input, and to find our indices. So and we know that 7's in there. So we can say that we're going to use this number that we use to subtract. That's difference with our target, and the indice of where we find the actual difference, right? So 5 and 7. 12 minus 5, that's 7. We have 7 in the list, so we're going to use the indices of 5 and 7. So 5 is at index position 2, and 7 is at index position 3. So 2, 3, right? So I kind of went over like a general idea of what I'm hinting at, what we're gonna do. So I think we kind of understand the problem. We gone over the input and output. We went some over constraints of the input and output. We went through a couple examples to showcase our mastering to our understanding of the problem. So let's go ahead and figure out what approaches we can do, right? So for some approaches, we can do nested for loop. So basically, for each a number and list, go through each combination with that num. And then we can do something Pythonic, I guess what people would say. So we can use the in operator. Use in operator. Because what kind of did in this example of example 2, where I said like target minus 5 is equal to 7. So if we know if there's 7 in here, then we can get the indices of it, right? So use in operator with the complement. And then what else we can do? We can also use a dictionary. Use dictionary slash hash map, right? Okay, but the only thing wrong with, okay, so that's not the only thing wrong, but some things to note about these approaches is that with a nested for loop, it's going to be O of n squared time complexity, because we have nested for loops, and for each element, we'll go through each element in the list. And then with the use of the in operator, that sounds like a good idea. Like, it sounds very simple. So if the complement is in the list, then we're going to get that complement's index and then just return the number, the number's index that we're using to find the complement, and the complement's index as well. So that's O of n time. But if we use this dictionary hash map, I feel like we're gonna get the same um, runtime, but our lookup time is going to be O1 because we're going to use a dictionary and a hash map. So I feel like we're going to go through this approach since it's just more efficient in general, right? So now that we know what kind of approach we're going to use, which is the dictionary and hash map, which I'm going to start right here, let's just go ahead and plan it, right? So the first thing I want to do in my code is I want to get user input first. So get user input of nums and target, which we can just do by saying like array user array is going to be equal to like a list and input dot split, right? And then we can say that target. Wait, I should do it like this. It's annoying me. There we go. And target is equal to int input, right? So we got user input already. Take a break. I'm kind of my voice is giving out. I've been doing this for like 3 hours already, so excuse me. And then once we have the user array, we can just create a hash map. So create hash map, store the key value pairs, and specifically I want to store um I want to store I'm gonna store oops, I can't think right now. So I want to store the key is gonna be so the key is gonna be equal to the index no, it's gonna equal to the value and the key value right now, and it's gonna be elements and nums, okay? And the key value is gonna be the index of the elements and nums, right? So that's how it's gonna be. So we can have O of one lookup time, because if we have the key, we can just say, okay, so at this element, get the index of it, right? And then what we can do is we can go through a for loop. So for loop to iterate through nums. And then you know how I mentioned about this approach where we say use in operator with complement? So what we can do before we get there, actually let me just yeah, before we get there, we want to get the complement first. So through nums, we can get complement, right? So what we can do is we can say for um for I in range, starting from 0 all the way to the length of nums. There you go. Um, we can get the complement. So complement equal to target minus nums at I, right? And then we can say if complement in, yeah, so this is the point I'm going to bring out where we use the in operator with complement. So to make it this easier for me, because this is what kind of made sense for me. So you know how we do like if complement in nums, right? This is what I would usually do, like when I first started this problem, when I first started to like do it by myself. I can just say, because this is O of n lookup time, the in operator, so we can just say if complement, and so if the complement is in the hash map, because since we're using a hash map, it's O of 1 lookup time, but if we said if complement in nums, right, then we would just return the indices, right? But if say if complement in a hash map, we're going to get the we're going to get the index of where that is. So get index of complement hash map. So that would we say a hash map, and the key that we're looking for is the complement, right? The complement, and then we're going to and so we're going to get the index of the complement in the hash map. So we can just return. Yeah. So at this point, we can just return the indices. So we can return I and the complement's index. So hash map complement, right? But if it's not there, then we do nothing, right? And we can just add the complement. Then we just add um, I the index value I and its index as a key value pair in the hash map for future use. So we're going to add hash map. We're going to add nums at I, and we're going to save the index. So if we go through this for loop, we're going to iterate through nums and get the complement. And then just like this example, where I said like, okay, so target -1, that's like 11, target -3, that's 9, but is 9 in the list? No. Target -5, that's 7. Is 7 in the list? Then yes, it's in the list, right? Just like stuff like that. But um, in this code, we would look at 7, and then we would be like, okay, so target -7 is 5 in the list. So, I mean, 5 is 5 in the hash map. And so it finds 5 in the hash map, so it returns I, which is currently at 3, and then it returns and it goes through the hash map with O1 lookup time to get the index of 5. Like, yeah, index of where 5 is at, which is 2. So that's what this for loop's gonna do, right? So yeah, so that's a good plan. Honestly, I just kind of made the pseudocode, kind of like actual code, but I just add some sentences over it. So, but this plan will work because we just went over it, right? So what I'm going to do is I'm going to just start with the problem itself. So I'm going to create main, I'm going to define main, I'm going to run main in the code, and then I'm going to define a function called get indices, get some indices, right? It's going to take in 2 arguments, right? It's going to take in an array of integers named nums and target. Oops, and I forgot to define it. So define, I'm going to pass it for now. So we create these 2 functions, skeleton basically. So now let's just copy paste our plan into code. So to start off, the first part of our plan is to get user input of nums and target. So let's do that in our driver. So user array is going to equal to an empty list, but we're going to put some input in there. And then once we get the input, we're going to split it. And for elements in the splitted input, we're going to turn those elements into integers, cast it into integers. And then here we have an array of integers already that we can put. Now we get the target. So target is going to equal to input. We can typecast that. This input by default returns a string, but we can typecast that into an integer. And then last thing to do in our driver code is to call get some indices with the arguments of nums and target, which in this case are user array and target. And we know that get some indices is going to return the indices of the it's going to return the indices of elements in the array, which represents the values that add up to the target. So we're just going to print out the list itself for our driver, so it makes sense, right? Then now that we're done with the driver code, we can continue with our plan. So the second step was to create a hash map to store key value pairs. So I'm going to say hash is equal to an empty dictionary because that's what hash maps are in Python. And then we're going to go through a for loop to iterate through nums and get the complement, right? So for I in range, starting from 0 all the way up to the length of nums. We're going to get the complement. So complement is equal to target minus nums at I, correct? And then from there, I want to say if complement in the hash map, oops, hash, we're going to get the index of the complement from the hash map. So basically, we're going to just return. We already have the index of nums at I because we found complement with it. So we can just say we're going to turn I, and the index of the complement itself, right? Because in this hash map we're storing the key is going to be the element in the list, and the value of that key is going to be the index of the element in nums, right? So that's how we get this hash, and then we're going to access the complement key. And then if that if statement doesn't run through, then we're just going to add the number that we're going through and as a key and the index as a value. So hash, we're going to have the key of nums at I, right? And then we're going to put in the index of that value in the list. And then if we go through this for loop, we're definitely going to find um, the correct indexes that add up to the target, right? So yeah, that's pretty much it for this problem. What I'm going to do is I'm going to go through these examples as test cases. So for the array, I'm going to add 1, 2, and 3, and then I'm going to have target 0 to 3. Then we get 1 and 0. 1 being 2. Yeah, this makes sense because here we say I, right, and 0. I and then the complement, right? So in this case, we already went through 1 once, so now we're here. So we do 3 minus 2, that's 1. Is 1 in the list? That's true. So what we're going to do is we're going to return I, which we're currently at the element 2, which is at index 1. And then we're going to return the complements index, which is 1, which is at index 0. So let's do the same thing with this example, where we have an array of 1, 3, and 5. 5 and 7. The target's going to be 12. So it's going to be index 3 and 2. We already went through 5 already. Now we're at 7. And we're like, okay, so 12 minus 7, that's 5. It's 5 in the hash map. It is, so we're going to accept. So we're going to first get I, which is 3, because that's 7. That's the element we're going through right now. And then we're asking the program the question, like, where is the complement in our hash map? And then we find it, right? Because we already have it as a key value pair. So we're like, okay, so at this key of 5, or the complement of 5, we're going to find its index in the hash map, which we already did in this line of code right here. So yeah, my voice is dead. My throat is very dry. Um, Yeah, so to evaluate this algorithm, again, I said it is O(n) runtime, but the O(1) lookup time is very helpful in this case, so we don't have to use if complement in nums, then get the index of that complement that's in the list, and then return I, and then yeah. So in this case, we're using O(1) lookup time, but if I just said like in the list, that'll be O(n) lookup time. So that's what it is in Python. So yeah, but either way, still both approaches work, but this is more efficient. So we're using a hash map, right? For space complexity, um, it's still O(n) because for every element in the user array that's inputted, we're going to store it in a hash map with its index, right? So yeah, yeah. So a good video.